you generally judge somebody who's not insane when their words, what they say they're going to do, what they say that their governing philosophy is, and their actions coincide when they're not contradictory, right? So you listen to Martin Luther King, you look at his actions, you see, okay, actions, thoughts, they're not very contradictory. There's something genuine and substantial there. Man's willing to die for a principle that he has expressed and described through reason what it is. You look at an Obama, not the same thing, right? A lot of flowery, nice words, actions, totally another universe. So a society which is fit to survive is capable of thinking with their mind's eye, so that they're not just being swayed by flowery language, but they're able to see with their mind's eye to see the breakdown of words and actions. And if they break down, then you could smell bullshit. You can start thinking critically about, well, what's actually being hidden from me? What is the actual truth that I deserve to know, or that my society needs to know to survive? In science, it's no different. I mean, there's certain, a lot of scientists today, you guys have probably heard this, will say that science cannot tell us why things are, they can only tell us how things are, right? You guys have all heard that type of adage? Now, I mean, okay, if you applied that to your daily life, that I couldn't know why things were, just how they were, you would be dysfunctional. And you could imagine like the insanity of a police officer who believes that, you know, who would say, well, I can only know how that car accident happened. I can only know how that woman got hit. I can know the velocity of the car. I can know how she died by getting run over. But I couldn't know why it happened. Right? If you actually applied that type of ethic to any other part of society which has to do something useful, it wouldn't work. Right? You would never know that there was an intention on the part of the driver to run down his girlfriend who he found cheating on him the week before. You know, that intention is something invisible. It's not something located in the velocity, in the matter, in the space-time of the action of the actual accident. And so, what the scientist is actually saying is, I don't believe in immaterial principles that cause material change. I don't believe in principle. I don't believe in causality. That's why you can only know the mechanics of what makes things happen. You can know the formula, but you can't know the reason why the formula is true. And we've all gotten that too in school. I mean, I remember feeling really disturbed when I was sitting in high school, being told I have to memorize all these formulas to pass a test, and being a little, I mean, you ask the questions to the teacher, the smart kids in the class, why are these formulas true? Why are these trigonometric functions, why are they true? And nobody can really tell you a very satisfying reason. You're just basically told to memorize it so you can pass the test, and some people are really good at memorizing. Still don't really know what that means. So, what I have printed out for most people here in the audience is the first few pages of Book 1 of Euclid's Elements. We're not going to read all of the definitions, but what Lyndon LaRouche has explicitly stated year after year after year after year is that one of the biggest problems intellectually blocking many of the leading people in society from understanding the true causes of our crisis, whether it be the breakdown of the financial system, whether it's our drive towards accepting the conditions of a nuclear war, whether it's the basic idea that we have to accept conditions of depopulation, of increased suffering for the many, for the benefit, monetarily at least, of just a few. One of the reasons why LaRouche has said that this has been permitted to happen is that there's been a pervasive belief that we have to adopt the methods of thinking of Euclid and sense perception. That the combination of getting society to be conditioned to think that their minds have to be changed to the laws of our five senses, what data we've taken from our senses, and the rules and definitions that we're told we have to abide by Euclid. Everybody here heard of Euclid before? Little? So. Okay, well. Okay. This is at the heart of a lot of the major unnecessary crises that are facing us. And it's by shedding light on these false modes of thinking that we're going to be able to see a very clear pathway out of many of the crises into this world of a new renaissance and a true human civilization based on creative reason that we're talking about. Lyndon LaRouche opened a paper not that long ago where he just said it in his own words. He said, "It should occur to us that in attempting to represent physical processes within the terms of space-time," so we are representing the mere shadows which the reality of physical processes casts upon our mental image of the kind of empty space-time which is the subject of Euclid's Elements. We are thus in Plato's cave, as famously identified in his Republic. We're talking about Plato before. Everyone heard of Plato. People have probably heard of the metaphor of the cave in Plato's works. Yeah? Anybody has not heard of Plato's cave? We've all heard of Plato's cave. Okay. All right. So what we're going to do, to put some meat on the bones of that statement, and what I said just before that, let's read the first 6 definitions of Euclid's elements and see what is there an internal contradiction in something which is the basis of how all of the leadership is being conditioned to think about economy, the quantum world, cosmology, musicology, a lot of these things that we are told are, you know what, I'm not going to talk about it. Let's just read Euclid and see if there's any contradictions. Euclid says, who wants to read the definitions 1 to 6? Volunteer. Evan.
Definition 1. Point is that which has no part. Definition 2. The line is breadthless length. Definition 3. The ends of a line are points. Definition 4. The straight line is a line which lies evenly with the points on itself. Definition 5. A surface is that which has length and breadth only. Definition 6. The edges of a surface are lines.
Okay, let's stop there. Does anybody okay, who said that they didn't know of Euclid before? They hadn't heard of the name Euclid. Okay. Euclid is a fellow who lived about 2,000 years ago. After Plato died, this is during the time of the height of degeneration of the Roman Empire. And Euclid was a fellow who was accredited with having codified in an encyclopedic format all geometrical knowledge that had been developed up until that time into one place, which is called 13 books. It's found in one big volume of pretty much descriptive geometry. So every part of geometry, Pythagoras' theorem, everything. What is the square, what is the triangle, everything that had been known was brought into one place. It's the first time that was done in an encyclopedic way. And he basically says, okay, anybody now who wants to study physical reality, if you want to be a true scientist, you have to study my methods, you have to obey my rules, because he begins his 13 books with a set of definitions and rules. And then, when you do that, now you're free to start going off on your own to explore the physical universe, right? Question is, where did he get these rules, right? Did he discover them, or did he impose them? And if you try to use the language that he's giving you to try to map out the yet unknown universe, do you run into any intellectual contradictions, right? Is there any place where your language breaks down with the actual curvature of the universe that you're walking into, that you're trying to wrap your mind around, that you've never seen before, or that you're trying to fit your data into and build a model around? Christine got at that very well by introducing the 3 different models that Kepler had to overthrow in discovering his laws of physical space-time, his musical space-time. So does anybody see any problems so far in those first 6 definitions, in his building up of the universe, or his definitions of what is the basis upon which the universe is built up? A point is that which has no parts. A line is a breadthless length. The ends of a line are points. A surface is that which has length and breadth only. The edge of the surface are lines. Any problem there?
1 and 3 contradict.
Go on.
I don't know, I just see it. How can a point have a line but not have a part?
How could a point?
Like, as he defines a point, is that which has no part?
Point equals, yeah, no parts.
But a line.
No width, breadth, or height.
Oh, sorry,
right?
Yeah. But the ends of
That's
a
a
line
point.
are points. But if it's a line and a point, there's a part.
Yeah, so a line is made up of is basically, he's saying, is bounded by 2 points, but the points themselves have no width, breadth, or height. And he says also here that a straight line is a line which lies evenly with points on itself. So if you think of a straight line, you start building up all of these points, and you start getting a straight line made of these points lying on itself. How many nothings do you have to add together to start getting something?
Can you please draw a point that has no breadth, width, or height?
Oh, I'm sorry, I just lied to you. I just put breadth and width and height on a point as ink on a board, right? Right, so right there, just my doing this is a contradiction. And then if you take this further into a surface, right, a plane surface is a surface which lies evenly with the straight lines on itself. Okay, so now all of a sudden let's introduce another dimension into our nothingness. Now if we define all of a sudden a two-dimensional surface, he's saying what's it made up of? A plane surface is a surface which lies evenly with the straight lines on itself. Okay, so we've got a whole bunch of nothings that have made up a straight line. We've got straight lines of nothings, essentially, that basically make up a surface. And then in a further book, he starts getting into three-dimensional geometry, and you can imagine starting to add these surfaces together to get, all of a sudden, his definition of a cube and other volumes, which are made up of a bunch of nothings. So basically, you'd pretty much be thinking that the universe is made up of a whole bunch of nothing. Right? So all of a sudden you'd have this equation that something, which is the universe, must exist, must be made up of nothings. Thus nothing is primary to something. That's fucking crazy. No matter how smart somebody thinks they are and how many PhDs they have that in the bottom of their thinking, they're in trouble.
That's why we have so many idiots.
Yeah, you're... So, okay, Plato's cave. Now, people often think of Plato as a philosopher. He was... some people would say he's a scientist. He was. All of his students coming out of the academy made the groundbreaking work of doubling the cube, of the astronomical work, the measuring of the circumference of the Earth in a time when people had no reason to believe that it was anything but a flat surface. These were all made by students and collaborators of Plato. A lot of the work, pretty much most of the work that Euclid plagiarized and turned into description was actually plagiarized and stolen from the students of Plato, namely, and also Plato himself, lest we forget that, the Platonic solids are called the Platonic solids for a reason. He discovered one of them, and he gave meaning to why they exist, these 5 solids. And only 5 solids that can be contained in a sphere. That's interesting. Why not more? That have these certain conditions to them. But who wants to describe the cave? Who remembers what the cave allegory is from the Republic?
I could try a bit.
Yeah, give it a try.
French, but,
en français, s'il vous plaît.
Ouais.
I think everyone here speaks French, yeah?
Ok. Ben, en fait, c'est que quand tu es dans la caverne de Platon, tu te rends compte que tout ce que tu as observé de ta vie était contenu dans la caverne.
Ouais.
Et ça a pris absolument quelqu'un qui venait de l'extérieur de la caverne pour te prouver qu'il y avait un tas d'autres choses, que la caverne n'était pas le seul endroit où il y avait des choses dedans.
Yep.
Il y a aussi une autre chose à remarquer, c'est que les personnes dans la caverne voyaient seulement les objets derrière les ombres. En fait, non, ils voyaient seulement les ombres de l'objet. Donc, ils voyaient l'objet derrière quelque chose qui cachait la vraie nature.
C'est ça. Ouais, il y avait des... Yeah, exactly. And there were actually people making sounds
Yes.
and casting those shadows onto the wall.
So
That
there's
people
two observations, that objects are beside, you only see the shadow of the object because something is hiding the true nature, and also you have to get out the how do you call it? The cave to see that these are not the only things you could observe.
Yeah, and then to be a true philosopher, not a fake philosopher, what do you have to do next after you discover that there's this higher light of the sun outside of the cave, and that what people thought was real is not true? What do you have to do then?
You have to get out,
you have to go back,
see other things, and you got to get back
in,
and inform the others that they need to do what you just did.
In spite of the fact that a lot of your personal comforts are going to be put at risk.
Yes.
Okay, that's important too. There's a few layers to this, because while you actually have the highest state of morality, of true love of mankind that's being exhibited in that very small poetic metaphor, right? It's a very loving thing to risk your neck to go back in and help your fellow man who don't even appreciate what you're doing, right? Most people who hear us warn about why we're on the verge of nuclear war with Russia or China or sponsoring Nazis in Ukraine, or they don't really quite appreciate when we make the point to them that they're living a lie, right? They feel a little bit threatened, and sometimes they even attack. So that's got to be a very loving thing that motivates you on the one hand. On the other hand, the basis of science, all of scientific true rigor is located there, because if you if you approached geometry, geometry does exist, right? There's a study of geometry, but if you approach it in a way where you don't run into the Euclid problem of self-contradicting yourself by misdefining what your foundation is, well, you'd probably not want to start from the bottom up. Don't start from a point and try to add dimensions onto a point that you've misdefined to the point that you now build up the universe from the small little point that doesn't even exist. Start from the other direction, because what would that look like?
What is the starting point from that?
Well, the starting point of that would be the universe, right? So if you look at people like Plato, like his collaborators, like the Pythagoreans, who studied in Egypt, the place where they were actually looking when they were building up their geometrical language was the infinite heavens above. They were looking at the cyclical motions that they discovered of planets, of other equinoxes, that we had these certain shorter and longer cycles that could be only detected when you started mapping out the positions of stars, of planets, and noticing that there's certain order that was invisible if you were just looking at the blanket of stars as a chaotic mess. It's only when you found new eyes to look at the night sphere, the sphere of the night sky, that you started realizing, wow, there's actually something there that I didn't see before. And if you start from the standpoint of projective geometry, this is something which the Pythagoreans, which Plato, and which our organization has been working very hard to revive. You could get pretty much a definition of points, of line, of surface, and of volume by starting with the volume. Don't start with the point. Like, for example, this used to be a perfect cube, and people they post things a lot on things, so it's gone now. Now it's not a perfect cube anymore, but it'll get the point across. Because if I look at the jets of light, the stream of light moving out of that projector, that cube, when I project it onto a surface, what does it look like all of a sudden?
Square.
Square. Right. Now if I take a square, right, a two-dimensional thing from a three-dimensional thing, and all of a sudden I just move to the side at the right angle, what do I start getting a proximity of here?
A line.
A line. Now if I actually had something short enough to if I actually had a little line, you could imagine me taking that little line and moving it again along the parallel to this stream of light, and you'd probably be able to imagine in your mind's eye a point, right? But it's not coming from nothing anymore. It's actually coming from a solid volume. It has something which has substance, which is now creating a non-contradictory definition of the two-dimensional and the one-dimensional domains. What we're going to be doing today, I don't know if I want to show this video. Let's not show this video. We can use our imagination. If you imagine, go back to LaRouche's statement. It should occur to us that in attempting to represent physical processes within the terms of space-time, we are representing the mere shadows which the reality of physical processes casts upon our mental image of the kind of empty space-time which is the subject of Euclid's Elements. We are thus in Plato's cave, as famously identified in his Republic. So imagine one of the consequences of this Euclidean method of thinking is that you have to suppose the existence of objects with no context. Right? You have to imagine the existence of a point or a line that just exists. That point just happened to be there. There's no context. There's nothing to define that line as different from another line. Right? It exists based on its definition, not how it was created. If you imagine a sphere, a Euclidean sphere, you could all see a sphere in your mind's eye, right? Just sort of floating there in the abyss of empty darkness. You can see it? Can you see that sphere has a center point in the middle of it, and it has a radius that can connect to all of its surface? Can you imagine that sphere getting bigger? Can you guys all see that sphere getting bigger? Can you just keep on imagining that sphere getting bigger and bigger and bigger? Infinitely bigger? Is there an end to how big that sphere is? Is there the biggest sphere that you can imagine? No, it can just keep on getting bigger, right? And that point, that center of the sphere, that little point in the middle of the sphere, can you imagine that point, not the sphere, but just that point just moving faster and faster and faster and faster and faster to the point that it's infinitely fast. You guys all see that? And there's no end to that, right? There's not the fast. You can't imagine the fastest point. Right. But if you take that thought object and you try to then map out what really happens, what's something in the physical reality that looks a lot like a sphere that has a growing quality? What's something that we see around us since we're kids?
Oranges.
Oranges do it, balls do it, but they don't really grow in front of us. It sort of takes a really time-lapse process.
A chewing gum.
A chewing bubble, yeah, chewing bubble, right? Any type of bubble, soap bubbles.
Or soap.
Salt bubbles, yeah.
Yep.
But they don't grow.
They could grow if you blow more energy. Well, they don't grow. What are you talking about? They don't grow.
I was hoping you would ask that, Luke.
Set up.
Fruits on the tree.
Eyeballs.
I actually wasn't planning on doing this, but since you said they don't grow, you can prove yourself wrong.
Let's make them grow.
Blow a bubble.
You mean without my intervention it's gonna grow?
No, it needs your intervention. There's always something that, yeah, no cause can happen without. Oh, there we go.
It didn't, well,
Well, those things were not the size that they were when you first started blowing on them.
yeah.
You can stop.
So what size was it at the beginning?
Well, if you go really slowly,
Baby.
Like a baby. You should do that in French. So you can see it.
everyone can see it. Well,
Well, you've seen bubbles. No?
so if you start blowing that chewing bubble, the Bazooka Joe or whatever, you start, or Hubba Bubba's better. It has bigger bubbles you can get. You start blowing that thing. If you never saw a bubble go, you would probably assume it would go on forever, right? Just like that imaginary sphere in your mind. But what really happens?
Running out of surface.
Euclid's bubble reversed.
And you got a face full of sticky chewing gum.
Right.
So and if you imagine something moving faster and faster, a plane, you imagine a plane moving faster and faster and faster, all of a sudden what worked in that imaginary world of that point moving faster and faster, all of a sudden we find that plane, you guys have seen what happens when a plane starts approaching the sound barrier? You guys have all seen that?
Yep.
Who hasn't? Okay, we all have it, I don't have to play it.
Well, no, I think we should play it.
Sonic boom, plane, I guess that should do it. There we go, that'll work.
Second one.
What? Second one? What?
You can do the second one.
The second one's better?
Yeah.
Are you sure? You've seen this before? You searched this out? Alright.
Yeah.
Okay, these are supersonic planes. They just kept going faster and faster.
Alright.
You get that sonic boom. It's going so fast that it actually causes the molecules of the air. Right, well, yeah, you actually have a phenomenon that releases a lot of sound that strikes you after it passes. And it's the condensation of the air around that plane is actually condensing. It's moving that fast when it. Inside those planes.
When I was a child, they would fly very fast, and they made this big bang.
Okay, these are supersonic planes that just kept going faster and faster. And you get that sonic boom, right? It's going so fast that it actually causes the molecules of the air. Right, well, yeah, you actually have a phenomenon that releases a lot of sound that strikes you after it passes. And it's the condensation of the air around that plane is actually condensing. It's moving that fast. When
Is there a person inside those planes?
there are people inside those planes.
When I was a child, they would fly very low and very fast, and they made this big bang, and I remember I would go flat on the ground.
From the bullets?
No, from the plane. It was going so fast.
You're talking about World War II, though, right?
No, that was in 1955, 60.
Oh, okay.
That's why they called us baby boomers.
That's
Why?
Boomers. Baby sonic boomers. How do I get the slideshow to go?
F5?
F5? So, What we didn't see in those are all of those planes that had to blow up, because before we actually started getting to breaking the sound barrier, we obviously had to start speeding test planes really, really fast, hopefully without pilots. Do you know if any pilots have died along the way?
I think there were.
Yeah,
think there were,
probably
yeah.
some people died, yeah. So what happened was people realized that the geometry of the craft that worked just fine in the realm of the regular, atmosphere that we live and talk in, all of a sudden that geometry that worked just fine for all of those laws of aerospace no longer worked when it started approaching this certain boundary condition where planes started blowing up. They just started breaking down, because for both the reasons that have to do with the fuel, reasons that have to do with the geometry of the plane, there was an invisible boundary condition that could only be overcome by a creative thought. Now, a creative thought that would allow engineers to create a new form of geometry that would then not only go into that higher invisible supersonic geometry, but once it was in there, all of a sudden, unexpected things that were not something you could have guessed were going to happen. Well, actually, that's not true. Generally, you could have guessed were going to happen, occurred. Like the fact that all of a sudden a lot less effort had to go into that plane's engine for a faster speed than would have occurred in the lower geometry. That was unexpected. And you'd think that if you never saw a sonic boom, if you had never moved anything to the speed of sound, that you could never have guessed that was going to happen. Except that the person who discovered the nature of the sonic boom, discovered and predicted it almost 50 years before it was experimentally demonstrated. Bernard Riemann, who LaRouche credits with having formed the basis of a type of geometrical language which LaRouche needed to use when he was a young man in the 50s, formulating his own discoveries into the science of physical economy, and which gave Lyndon LaRouche the ability to become the world's leading economic forecaster on record, by simply recognizing that it's not money or some other form of object that gave value to an economy, but it was rather the boundary conditions being shaped by the ideas that translated back into either an increase or decrease of scientific and technological progress. Because if you shut down scientific and technological progress, all of a sudden, boundary conditions which weren't there for you, things get tight. Our ability to sustain our growing population gets harder and harder, to the point that we start justifying a population collapse. And the way that we can understand what the solutions are to our problems are by literally thinking about what are those boundary conditions, and how do we do like they did with those aircrafts and change the geometry, the organizing principle of society, to now move in that newer domain of action that we're going into as we enter the space age and the new age amongst nations that have to find a new way to think, to cooperate with each other that has never existed before. But with nuclear bombs all over the earth, you kind of have to. There's no choice about that anymore. So, this requires a rediscovery of an anti-Euclidean, anti-sense perception mode of thinking, which incorporates music, poetry, and statecraft together in one mode of thought, with people courageous enough to improve their own capacities to understand and then act upon those. What I'm going to do briefly to showcase one of the elements of this battle in action. For those of you who were here for the first presentation of the day, Jean-Philippe showed a picture of the Dark Ages and the population collapse of the 14th century, and then this amazing spike from the 14th century to the present of population growth as well as quality of life. I think some of you weren't here for that. But the point is that the thing that got us out of the Dark Age, with all of its boundary conditions of ignorance, lack of technology, lack of hope for the future, were a few singularities, a few individuals who stood out from the mass and who saw a better way in their imagination and fought to manifest new ideas that had never existed before into reality, both in statecraft, the idea of the nation state, the purpose of laws based upon the general welfare, as well as of science, of new discoveries that had never existed in medicine, physics, and beyond, and music. Kepler we got to see a little bit of, who was a follower of a great thinker, Nicholas of Cusa. Leonardo da Vinci, who was inspired by Cusa as well, and who inspired Kepler. Were all examples of these these great geniuses who are of a high moral caliber. And coming out of this wave, we had a fight that was waged around the idea of what is light, which will be what we're going to play with a little bit today to solidify in our own minds. In human history, as we just said, we're all made up, we're all in a certain sense particles, right? We're all in a sense born into this world and we die. But we're part of a wave as well. Now, in thinking about the sphere and thinking about the point moving in a straight line, right? And that growing sphere, we're actually dealing with something which has been at the heart of the battle for a long time. Either, if you're a logician, you'll say something is either curved or it's straight. It can't be both straight and curved. And if you're talking about objects, it's true. An object is either round or it's not. It's straight. But if you're thinking about an action, all of a sudden, that's not true anymore. Something can be both curved and straight. Light is a good example of that, because what we have is a situation where light does, I mean, would you guys all say that light moves both curved and straight?
Yeah.
Do you see how it moves straight in a straight line? Well, this was a great example of it, right? Beams of light moving through the shadow, the clouds is a great example of that. How does it move in a curved or a spherical form?
Through water.
Through water, in what way?
Liquid. If it's a liquid in a glass.
Liquid in a glass? But how does it move in a sphere, in a...
When you look at the light going in, it kind of makes like a circular effect in the.
In the glass? But that's a circular glass.
Yeah.
Okay. Well, what if you turned on a candle in the middle of a dark room? In which direction would those light rays emanate? In one direction or in many directions? Many. And if you took people and just surrounded that candle at 5 feet distance, and then took more people and surrounded that candle at 10 feet distance, would there be anybody who would not see the candle? Or would everybody get to see the candle? What would be changing for the people at 5 feet versus 10 feet?
They'll see the candle.
They'd all see it, but would there be anything?
The
The intensity of the light would be reduced.
Yes.
Okay. So what you have then is a demonstration that the light is emitting in all directions, right? And if something's emitting from a center point in all directions, what you have is a spherical emanation, though with a reducing intensity as it moves away from the point of cause. A lot of people, there was a big battle that waged around what is the nature of light and how does it move through space, which was approached by a grouping of Euclideans, people who are trying to use the rules of Euclid and sense perception, a little mix of the two, around this cult figure of René Descartes, who said that they have all the formulas, all the solutions, but it didn't really satisfy a lot of the thinking people who were actually Platonic in their mode of thinking, and were a little disturbed by the reasons given for why light behaves the way it does. We're going to go through just a couple of examples. We're going to play around a little bit with a laser beam that they unfortunately didn't have in their day. Now, Descartes' method, just to get clear on this, he just wrote it in his Dioptrics, and it was in 1637 that he was given full credit for having been the guy to discover the nature of how light moves when it reflects and refracts off surfaces. And he says that his method and his philosophy of research into the unknown, who wants to read this?
I'll do it. Okay. All the conduct of our lives depends on our senses, among which the sense of sight being the most universal and most noble. There is no doubt that the inventions which serve to augment its power are the most useful that could be made. Now, having no other occasion to speak of light here, except to explain how its rays enter the eye, and how they can be deflected by the various bodies they encounter, there is no need for me to attempt to say that its true nature is, and I believe that it will suffice for me to make use of 2 or 3 comparisons which aid in conceiving it in the manner, properties?
Which seems to me.
Oh, sorry. Which seems to me the most correct to explain all of its properties, which cannot so easily be noticed. In this I will be imitating the astronomers, whose assumptions, although almost all false or uncertain, nonetheless, because they agree with many observations that they have made, never cease to allow the derivation of many very true and well-assured consequences.
So all of the conduct of our lives depends on our senses, right there. I think Plato's cave demonstrated that that's not necessarily true if you're a true philosopher. You go against what your senses are telling you because you're going to risk getting hurt to stand up for the truth.
Is that going against intuition?
Huh?
Is that going against intuition?
I think it's more like redefining what intuition is. What do you mean? How do you mean what you're thinking?
Well,
Do you mean what he's saying or what I'm saying about Plato?
what he's saying.
That this goes against intuition? In what way?
Well, in terms of, like for instance, the sentence where it says, the most universal and most noble, there is no doubt that the inventions which serve to augment its power are the most useful that could be made. Hold on a second. Never mind. No, it's okay. No, I had a contradictory moment in my mind. Okay.
Well, I mean, it is counterintuitive in the sense.
Isn't he saying the same thing as Ptolemy? Saying, there's no need for me to attempt to say what its true nature is.
Yeah.
And I'm intimidating the astronomers who are almost always false.
Yeah, exactly. Yeah. No, that's exactly it. And if you actually...
It works, on paper.
Yeah.
Yeah.
And if you actually if Kepler had this guy's philosophy, he never would have refuted Ptolemy or Copernicus or Tycho Brahe, whose models he obviously did refute, right? Because all of their models described sufficiently what their senses told them about the changing positions of the planets. And if your formula and your model describes the changing positions, doesn't that make it good enough? It works, right? You could predict things where they're going to be, in a sense, within statistical probability,
Pays the bills.
limits. Pays the bills, yeah, you get a lot of money if you're good at it. So he actually doesn't really care about truth, and he is extolling the idea that our senses have to govern all of our motives, and sight being the most noble and best. So he's saying, okay, you can be a great genius like me and discover all the formulas I'm discovering, although evidence has it, as you can imagine, that he, like Euclid, ripped off most of those things that he's attributed for having discovered, but still. But he's saying you could be a great scientist like me if you just adopt my method of thinking, which is not really thinking at all. You're just being a slave to your senses. One of the places that this controversy started really getting hot on was over the idea of light. And as I said, it both reflects and refracts. But what is it actually doing? Now, Descartes said you can know that light, when it reflects off of a surface, if that surface is straight, if that light strikes at any place on the surface, you can have this little angle of, I believe this is called the angle of incidence, and an angle of reflection, so that those angles will always be equal. Always. There's a lawfulness there. Anytime you have a reflection on a flat surface, the line of reflection will be equal, or the angle of reflection will be equal to the angle of incidence. He also said that line is traveling, that light is moving infinitely fast, because light, after all, is divine, and the divine is infinite, so thus the creation of the divine must also be infinite. And since we can't produce any experiment to demonstrate how fast light is moving finitely, the way we can for sound, I can go to a canyon and shout at the edge of the canyon and hear an echo, so I know that sound is finite. I can even measure how fast it is. It's really hard to think about what type of experiment you could conduct on light to demonstrate that it's also finite, because it's really fast. But so he said, okay, common sense tells me that it's infinitely fast. It has this rule where it has equal angles when it reflects, and that's sufficient. And it reflects, and thus he could say logically that it reflects because of the equal angles. So why does light reflect in the way that it does? Because the angles are equal. Circular reasoning, right? You guys heard what circular reasoning is? So, sure, okay, but this obviously disturbs people who like to think. One of the things we're going to do today, can we prove actually that that's even true, or do we just believe that do you guys all believe that that's true? That light does, that these angles are equal when light reflects off of a surface? Do you guys believe that to be true or false?
A flat surface?
Flat surface, yeah.
Perfectly flat surface?
There's no such thing as a perfectly flat surface. Sufficiently flat to do the experiment with.
Okay.
Like that mirror. Do you guys think that would be true or false? Would the results coincide with what we are saying here? It would coincide? Have you want to actually try it to see if we could come up with an experiment to prove that that's true?
The prism experiment.
Prism experiment. Oh, prism experiment and a reflection. Why do you need a prism?
Oh, no, I mean, it's not a reflection.
So if we just had that mirror and we just had a little bit of string, could we prove that that is actually true? That light is moving in a straight line and it's bouncing off that surface in a way that we don't need a laser pointer. You guys want to try it?
Yep.
Because so far we don't know it. I mean, we're being told the formula. I think it's probably true, but if we don't actually know it to be true, then it's not really useful, right? Because we don't want to fall into the Cartesian problem. So who can come up here and think of a way to test that out using that string and the mirror? Is there an experiment we could think up, create in our minds to prove why that thought might be true? Or no, let's say no string. Let's just say the mirror. And I just don't want to use the laser pointer, Evan, just because it could blind somebody. Can you see me?
I can.
What does that mean?
Well, maybe a ray of light went into the mirror there and then came to me.
Thank you. Well, that could be true, yeah, because obviously if you're looking at my eye and I'm looking at your eye, it must mean that there's some light that's bouncing from that mirror to your eye to my
Does
eye.
it have to be light?
Does it have to be light? I don't know.
Yeah.
What do you mean? Are you saying this could be like
Could I see you
concrete or
without
what?
light?
I don't think so.
Okay.
Could we say? So we would assume then if we stand at equal distances. Yeah, somebody else want to try this? You want to give it a shot? With Luke. There, Luke, there. You're doing well.
So you need me and Luke.
You and Luke, yeah.
Okay.
How would you be able to prove then that there's an equal angle? You guys can both see it. That's a good start. Can you prove it for everybody else in the audience that that's actually true? That there is an equal angle from both of you guys, that light travels.
Okay, well, if we mark something here,
Yeah? Do that.
okay, I'm gonna make this to this point.
Mm-hmm.
If you look at it, or if I look at it, and you look at it,
Yeah.
you're looking at it with, like, let's say, which eye you're looking? This one or this one?
Your right eye?
It's not the two at the same time?
Close one eye.
Okay.
And you close one eye.
Okay, so you're doing the one open, okay?
Mm-hmm.
So if I'm gonna, my hypothesis is that I'm gonna align my eye, which is open, with the dot, and I'm gonna see your eye, and that will have.
And then you have to ask, will you, if you do that, will he see your eye through that dot
yeah.
too?
So that's the thing. If I see it, do you see my eye
On that dot.
on the dot?
No, I see the dot on your eye.
A poet.
Okay.
That's an inversion.
So now we see something, but how do they see what we see?
Well, you could.
Only just guys, they don't see what we see, man.
No, they have to take your word for it in this case. They have to actually get up and take turns doing it, which we don't want to do right now necessarily. But why don't we? How about that string? Could we use that string in some way? If we get a third volunteer to hold. Yeah. Oh, how about one of you hold one side, and one of you hold the other side, and a third volunteer. Martin, you want to come down? Can you?
Like the price is right.
Good try. Come on. Yeah. No cash prize. Can you put your finger on the string on the
I
dot?
do the same.
Yeah.
On the string.
Yeah,
on
get
the
2
dot.
straight lines here. And follow his hand up. Okay. Okay. You guys see each other's eye?
Yes.
On the dot?
Yes.
You do too?
Yes.
Okay. I'd imagine if we took some sort of a... I didn't really think this through, so let's take 2 relatively equal markers. I'm guessing if I space them out equally to the point that their caps are touching the thing.
Why don't you
equal
go to the
sides.
point where they equal the length of the marker?
Okay, equal marker, that makes much more sense. Okay, you look about equal, their distance?
Yeah.
Okay, you guys all see that?
Yeah.
Okay, can we say, next question, that that's actually the shortest path? Why couldn't I say that this, because there's infinite possible paths that that light could have taken. Is there a way to prove that that is actually the shortest path of all the possible paths? Because the other school of thought of people who didn't like what Descartes was saying, that it's true because of the formula, they said, well, no, we want a principle. And many of these people, like de la Chambre, who was a famous, relatively good scientist, said, no, we want a principle of shortest path. They said that's the reason why it is. Because you can prove that that path that that light takes is the shortest of all possible infinite paths. But how can you prove that that's true? How can you prove that not some other path would be a little bit shorter than that one? Where both angles are equal of reflection and incidence. Can you guys think of a way to prove that? Okay, try this. Does anybody have a thought before I throw out mine?
Well,
My 2
just a
cents and
second.
spoil it?
What's your name again?
Juan, mets ton nez plus proche de chose, parce que...
Oh yeah, you see it, right? You see his eye? You see Olivier's eye?
I need to move.
Yeah, you gotta just make sure that you're both in sync, in harmony.
Because mine looks shorter, right?
Yeah, make both your
Usually I don't feel like
here,
this.
make the strings the same size. So make your 2 strings touch each other while your finger stays in the middle. Olivier, make your string touch his edge there. Make sure they're the same size. Pull it up.
Great.
Okay. Do it. Okay.
Have to look to your eye.
Yeah, look to his eye. And when you're
I'm right there.
okay, you got it.
Yeah.
Okay, his eye's on the finger. You're right. You guys will see that?
Yeah.
Okay, so those angles seem to be equal. Why is that? Is it true to say that that's the shortest? Is there a way to prove it? What if you move your finger a little bit this way? Keep your not yet. No. Take it off. Original position. Okay. All right. So you keep your hand in position. You keep your hand in position. Don't move your hands. Okay.
Good.
You guys feel a certain amount of tension. Okay. You in the right position.
Yeah.
Okay. You feel a little bit of tension. Tension. You see. You
Yeah,
pull
on the keyboard.
a little bit of. Okay. Don't let that tension change. The physical tension, keep it the way it is. Okay. Good. Constant. Move your finger. Move your finger, Martin, to the right. Create another.
Right.
Yeah. Create another pathway now.
Like here.
Okay.
Do you guys feel anybody had their tension increase?
Mine.
Yours.
Yeah.
Did you feel your tension increase?
It's looser.
Okay. Yours got a little bit looser, but yours got tenser.
Yeah.
What about here?
Oh yeah.
Both of us is feel it's
Now my tension increase.
Yeah.
I don't want.
So what you have is that your tension is increasing anywhere you put your finger, right, from the original position.
Because look, I will equilibrium.
Looking for you had an equilibrium to start with,
Yeah.
and then as soon as you move that same size string, that same size light pathway, because light was moving along that string in a sense, right?
Yeah.
There must have been at least some light doing that. All of a sudden the tension increased, right? All of a sudden, so that means that would have been a greater distance. It was requiring it would have required more string to satisfy that requirement of moving from.
We're looking for equilibrium.
Because it was pulling down, that string wasn't long enough for him to keep his hand in the same position. Because that was their job, was to keep their hands in the exact same position as they were at the beginning. Right? So as soon as you move in one direction or another, and you get more tension pulling, yeah, you got a little bit less. But
So this is supposed
You
to
feel your
demonstrate...
I also feel more to go.
yeah. less, more. Okay.
But what does that prove?
That proves that for no tension for that tension to have been constant as it was at the beginning, it would have meant that that string would have had to have grown proportionally as the angle changed. So that string would have had to have grown for that tension to be maintained, or they would have had to move their bodies closer and further away from the mirror as that point touching the mirror changed. There's another way of proving it, though. That's just a physical way. One way to do it geometrically, because the physics is, it's good to have a starting point, but if you want to really, really know it, like really, really drive it into your knowledge banks forever. Oh my God! Oh no! Somebody put a permanent marker in the temporary marker bin. Oh, that's so bad. Marker permanent, of course. Well, it's a really nice
Don't
word.
worry, it's got no dimensions, so.
Yeah, thanks. Thanks a lot. Oh boy. Oh, that's so bad.
You could get it off this ways.
Thanks.
Alcohol will pick it up.
Yeah, but I'm gonna ruin the gloss of the. Anyway, it doesn't matter. Okay, so if we have our light going in, right? Then another way, and we have our angle of incidence and our angle of reflection. Is there another way of proving that this line would be longer of a distance than this line, geometrically? Just using our reason? Can you guys come up with a way to prove that that line's actually bigger and not the same size or smaller than, let's say, like A, B, C versus A, X, C?
Well, A, B, C, wouldn't that be a 90-degree angle?
It doesn't have to be, because this law applies to any,
Oh, yeah, okay, any 2 points.
yeah, any 2 points. So is there a proof that you can create that would solidify in your knowledge that that would always be true?
Est-ce qu'on doit additionner la longueur, les mesures des longueurs?
No, you don't have to get any distances, doesn't matter.
Could you
No numbers are necessary. Pure qualities.
What are you trying to ask here?
Can it be proven geometrically that ABC is going to be the shortest possible pathway of all infinite possible pathways, and I just chose one random one, AXC, that would be longer than ABC, and that ABC would be the shortest? Yeah?
Does it have to do with equality?
Yeah. In what way?
That from B to C is half of the total of ABC, and A to B is also half.
Well, that's true. A to B is half of ABC, and AB is half, but that doesn't really give us the answer to the question, how is that shorter than AXC?
Oh.
Now, if it wasn't so late, I would really just encourage us to get some paper and pencils and play with it, but it's getting kind of late. You guys want the answer, or you want to look at it a little bit more?
The answer. We're lazy. At least I am.
Euclid's ghost is alive in this room.
Or if you have a clue that could really help us say it by ourselves,
You're throwing the challenge at me. Turn the tables on me, eh? Not cool. Well, thank you. Is it true that this is the radius of the circle?
Yes.
Would that always be the radius of the circle?
No.
Oh, I mean, any point on the circumference of the circle to the middle, that would always be the radius, right?
Yes.
Right, okay, and it would bounce off another radius, right? Would that mean that if I put a line continuously straight through the circle, would that be equivalent of a distance to, like, ABC? Would that still be AB, let's say call this D?
Yes.
That's the same distance?
Yes.
Okay. Does that help us yet? Prove why this distance is actually shorter than this distance?
Well, it seems like it's unimputed.
It's not going through anything. It's just purely distances. We're not even
So
looking
it
at
could-
the,
it's
we're not even
fine.
looking at the physics right now.
It's no.
No, not even look at the physics. It's just an example of the usefulness of geometry if done responsibly.
Well, if I'm
It's not like we want to throw geometry in the junk bin either.
Because it doesn't meet with the radius? Is it, why is it shorter?
Well, no. How about this?
Like the C to X?
Is c to x,
Yeah.
is that distance from x to c the same as x to d?
Yes.
Do you all agree with what you gave?
Yeah.
Yeah? So x to d is the same as x to d is the same as x to c. All agreed?
Yeah.
Yeah? Okay, so now we have a new way of looking at this, right? We've given ourselves new eyes. AXD, does that all of a sudden look a little bit longer than ABD?
Yes.
Aha!
Yes.
A little bit easier to see right now, right? Who still is a little bit confused about that? No? Okay, so we can actually prove that ABC will always be, whenever a line goes from the circumference to the center of the circle back to the circumference at equal angles, it will always be the shortest possible path between these two lengths relative to anything else you could possibly want of infinity. So the infinite spectrum of choice, we can prove very simply that that's always going to be the shortest one, right? Because you could do what you just did for anything here and get a triangle, right? You could always do that. Yes, Evan?
I guess I'm just going to try and point out a pattern or similarity. But ABC is equilateral triangle, it's all the connected.
ABC?
Yeah.
This is not equilateral triangle, no. Only in one
Oh, sorry.
circumstance, but we don't.
Um,
Yeah, just this is a random angle.
whatever. But also CBD is the same triangle as ABC.
C, B, D.
B,
Uh,
and then D to C.
that might always be the case. Like if we go from A prime to B to let's call this D prime. In that case, yeah, you could probably say that this angle.
Well, CBD.
Well, then you have A prime B C prime, which is a big triangle like that. And you're saying what? What are you saying, Evan?
Well, the relationship between the triangle of ABC
Yeah.
and the triangle of CBD,
Yeah.
no.
No, it wouldn't be the same, right?
No,
This triangle is
C-
very different
Not,
from
no,
this
not
one.
Your other D.
your other D.
Oh,
the
this-
other
this D.
CBD.
Oh, this one.
The first one, yeah.
Yeah. CBD.
Yeah.
Yeah.
And ABC,
ABC. Yeah.
what's it called? They're the same triangle.
You might only find that in one instance, probably where, you'd probably only find that where you'd have a like a square. So where you'd find that square, you'd find that to be true, right? Where that would be the same as that. But in every other instance, I don't think you would see that. Like if you had this, that wouldn't necessarily be true anymore, right? That triangle is no longer the same as that triangle. So what you've described is just true in one instance. It wouldn't be true as a general law or anything like that.
But as you said, the CBD
Yeah.
is the most perfect you can get.
CBD is all I'm saying is this is the shortest path.
Yeah.
Yeah. It's the shortest path.
But everything that is similar to that shortest path is also the shortest path. That's all I'm just saying.
Possible. Maybe. So is that the law? That light always follows the path, the shortest path as it moves through space. Is that okay to say that? Do you think we all prove the law of light's motion? Yeah? You all agree? Martin, you agree? Okay, but then why is it that light doesn't actually do that? Because all of a sudden, if you, because when you're dealing with reflection, you're also dealing with another phenomenon of refraction, right? You guys know what refraction is? Good old soap. It's still good. Okay, so now we got. Guys, who has played with refraction before? Watch guys, come a little closer here. You guys know what refraction is, right? When light moves from one medium to another, where's that laser? I have it.
It's right there.
Okay. Can you guys see the soap? Okay. So what do you think is going to happen when I put the light through the air and into the soap? Will it go in a straight line? And will it... Like, let's say I have that light moving from the laser to that dot. You guys all see that? When I intersect the soap with the path of the light, is that light going to still be hitting the dot?
No.
What do you guys think? Yeah, it's a good idea. Here, why don't you hold this? All right. Keep your hand still, because my hand it's not still, isn't it?
Oh, wow.
I don't have good muscle control like you. Okay. Here, why don't you? What's your name? I'm sorry.
Anna.
Anna, could you do me a favor and move the soap to just put the soap bucket on top of the
Soap control.
the dot? Don't move. Yeah, right on top of it. Put it right on top. Put it right on top. Okay.
It's okay?
Wow, it actually went right through.
It went right through with not moving. Huh.
Yeah, that's right.
Yeah, of course.
Doesn't that
Let's try this.
also... But doesn't that also...
Okay, I'm going to point at this pencil, okay? All right? Now, what does that light do when all of a sudden it's intersected with this thing? Okay. Does that light pathway still look like it's moving in a straight line out of my laser beam? Or does it look like it's bending?
It's
bending a bit.
No, it's straight. It's only at the round part here that looks like that.
Only the round part does look like it's bending? You're saying it still looks straight?
That's straight.
I think it's the
That
point
looks
where it
straight.
touches the surface
That's what-
and where it
Right.
exits
It's
is
straight.
the same.
That's not straight.
You don't look at it straight. You only see straight.
Huh?
I mean, in the liquid.
Here, do you want a thing in water?
No, you can't see through it.
No? Okay.
No, you can't see through it. Now, I remember learning in school when I was young that Native Americans, when they would go fishing, they would always throw their spears. You know, well, a little bit below, a little ahead, yeah. So whenever they would see a fish, can I use that?
Yeah.
Whenever they'd stand in the water and they'd see a fish, with their eyes, they would actually shoot their spear. Right. They would actually shoot it this way to actually get where the fish actually was. So that, right? They knew that light was actually bending. The path of light, when it went through the water, would bend a little bit. This poses a problem. We can turn on the lights. I'm going to try to replicate this maybe over the next time we do this type of class, so that I could set things up in people's minds so that that problem is more clearly defined physically. One of the problems that the dot we were looking at was also following, it had light obviously had to hit the dot and move through the medium of the solution and then come out through the air into our eye. So that itself had an angular pathway. So we were deceiving ourselves when we were pointing at the dot saying, oh, it's hitting the dot. It's just that both the light from the dot and the light from the laser beam were both bending at the same angle. Here, let's turn on the light again. Oh, you can do that? Here, can you erase that? I'm going to have to use that for you. You can do that after.
Yeah, okay.
Thanks. you. Yep. So what we thought of as the shortest path law actually only works for reflection. It doesn't actually work for refraction. Right? For the simple reason that if light were to have moved from the source in a straight line down to where it hit through, let's say, z, so x, z, y, if versus x, a, y, if it just moved in a straight line, would you all say that with me that it would be shorter than if it moved this way? Yeah, you all agree with that, right? But it doesn't. It doesn't take the shortest pathway when it goes through from one medium to another. It all of a sudden takes a longer pathway than the shortest. So Fermat, one of the greatest scientists of his day, wrote to this fellow, Marin de la Chambre, who had written a book on light to refute Descartes and provide a better set of reasoning for why Descartes' observation is true. Fermat went in to help him, because Fermat basically said, you're missing something. Where de la Chambre said, no, Descartes should be obeying the higher quality of principle that light always obeys the shortest pathway. Fermat said, no, you're shooting yourself in the foot if you keep saying that. Stop saying that. And he writes, but since it served us well for reflection, can we derive some use from it for refraction? That's the law of shortest path. It seems to me that the thing is easy, and that a little geometry will allow us to tide over the difficulty or get out of trouble. I will not bother myself with the refutation of the demonstration of Monsieur Descartes. I contested it with him a long time ago when I spoke to him, but he never satisfied me. Fermat and Descartes had a correspondence 20 years earlier. At this point, Descartes was dead. But Fermat even then disagreed. He just didn't have the solution at the time. Sorry, just quick. Descartes was also famous for having discovered the law of refraction. And he basically proved that, he didn't prove anything actually. He just said that the cause for refraction, which wasn't known for a long time, because why of all of the pathways, why would light bend as it does from one medium to another in the pathway that it takes? And for every medium it's different. For denser mediums, like if we had jello here, which I was hoping to make, it would bend even more. That light would have bent even more than it did in the soap. And it would have bent a little bit less in water, but it still would have bent. So Descartes said, well, the reason for that, or the formula that describes it is that the angle of incidence has a certain relationship to the angle of refraction, which will always be constant for two medium, for whether it be like air and water.
Is Fermat saying this?
No, this is Descartes saying that this formula is true and that's all you need to know. And the way he talks about it is sine. So he says, if you take the sine of this angle, and you take the sine of this angle, you'll always get a certain proportional relation, which will be constant, right, all the time. So whether it's like, in this case, let's just say arbitrarily it's 3 to 2, it'll always be of that same 3 to 2 proportion. It's a constant. It'll be different.
Do you have to measure that separately, though, for each substance?
He had to do a bunch, but they found that
a
there's...
reference table after a while?
Yeah, they ended up building up indices, refraction indices that you can play with. But again, the formula doesn't tell you why it's true. And simply saying the shortest path, the principle of shortest pathway doesn't tell you that it's true either, because that doesn't work for such phenomenon. So Fermat says, the use of these compound movements is a very delicate matter, and one which must not be treated or employed without great precaution. I compare them to some of your remedies, which can be poisons if they are not well and duly prepared. It should therefore be sufficient to say on this account that Monsieur Descartes has proven nothing, and that I am in agreement with you in rejecting his ideas. So I agree with you. We both don't like Descartes' method, but you're missing something. But it is necessary to move on and find the reason for refraction in our common principle. which is that nature always acts along the shortest and easiest paths. It seems at first that the thing could not succeed, and that you have yourself made an objection which appears invincible. For since on page 315 of your book, this figure, the two lines CBA, BA, or CBBA, which contain the angle of incidence and that of refraction, are longer than the straight line ADC, which forms the base of triangle ABC. It follows that the ray from C to A, which goes through a shorter path than that of the two lines BC, BA, should, in accordance with our principle, be the sole and true root of nature, but which nevertheless is contrary to experience. So basically just saying the shortest route being the straight line ADC, so he calls it ADC. This line here, it's a straight line, should be shorter than the two lines BC, BA. BC, BA. So BC, BA. BA. But that's contrary to experience. But we can easily extricate ourselves from this difficulty by assuming with you and with all of those who have treated this matter that the resistance of the media is different, and that there is always a certain ratio or proportion between those two resistances when the two media are of a certain consistency and internally uniform. And then this freaks out all of the Descartes followers at this point, who say, well, basically he says, our demonstration is based on the single postulate that nature operates by the most easy and convenient methods and pathways, as it is in this way that we think the postulate should be stated, and not as is usually done by saying that nature always operates by the shortest lines. We do not look for the shortest spaces or lines, but rather those that can be traversed in the easiest way, most conveniently, and in the shortest time. Okay, do you guys see what he's saying here? How he changed it? So it's not the shortest path, it's the easiest path, the path of least resistance, and that nature selects a pathway which is the most efficient, the most economical of all the infinite possible options. And this has huge metaphysical implications now. This means we're in a totally different type of universe than the one that the Descartes and the Euclideans wanted us to believe we were in. Because this means all of nature actually has a certain type of a will to judge a best pathway amongst an infinite possible spectrum of pathways, right? Geometry is not in itself a cause of anything. It's that there's a certain intention, a certain direction and intention of the universe which geometry has to obey physically. And this again causes all of these demons to just freak out, and Fermat is attacked widely, and it's a huge controversy now. And one of the leading followers of Descartes in France is this guy Claude Claircellier, who wrote to Fermat attacking him, saying, the principle that serves as foundation for your demonstration, namely that nature always acts by the shortest and simplest paths, is but a moral principle and not at all physical, which is not and could not be the cause of any effect of nature. It's moral to say nature acts the best, and that's not real. It is not because it is not this principle that makes nature act, but rather, this is where he gets his view of what causes it to act, but rather the secret force and virtue that is in each thing, which is never determined to a particular effect by this principle, but instead by the force which is in all causes and which comes together in a single action, and by the disposition which is actually found in all the bodies upon which this force acts. And it could not be such the cause of any effect of nature. Oh, and it could not be such the cause of any effect of nature, because otherwise we would assume nature to have knowledge. And by nature, here we mean only that order and that law established in the world as it is, which acts without foreknowledge, without choice, and by a necessary determination. You guys see why he's freaked out? You guys see why he's, yeah? So what's Claircellier's view of nature? Is it a nature that actually allows for creativity and freedom? Or is it a nature that's completely deterministic? It's organized by rules, set fixed rules that just always have to be followed, mindlessly, with no judgment, like a good slave. So obviously he thinks of nature as a dictator, that wants the world, minions to follow mindlessly, with no morality. Morality is not something in nature, it's just something that keeps the slaves under control. It's useful, because otherwise they would run havoc on the place and the masters wouldn't be able to stay in control. He doesn't believe in any justice, he doesn't believe in any truth. So from there, I think that what we're getting at is looking at the amazing revolution in science that came out of the circles of Fermat, like Huygens, like Leibniz, who worked very closely with Huygens, who worked with Fermat. What we start getting at is that there's a whole science of economy based upon the laws of nature, which is created. And LaRouche always says that people have to study Leibniz, not just for one or two reasons, not just because he's discovered the calculus, not just because he was a leading political figure in correspondence with the Tsar Peter the Great, and the intelligentsia of China or the Winthrops of the Americas. Not just because he had a grand design to overthrow the oligarchy using what he learned from nature, but he also discovered the science of physical. He was the founder of the science of physical economy that had continued to evolve in a certain direction, which LaRouche took up the torch for when he was a young man coming back from World War II, and was able to take to a much higher level than Leibniz or his followers were able to take it. His followers being the people around Benjamin Franklin, like Alexander Hamilton, who created essentially created the science of political economy of the American Revolution. This is not monetarism, it's not communism, it's something which we have every right to know, and that we've been deprived of being permitted to understand, because the oligarchy wants us all to think of ourselves as particles, just floating like a little hedonistic beast, searching for pleasure and avoiding pain, the way Adam Smith says that we are, and the laws of the marketplace will demand that we assume that we are. But as soon as we recognize that we both have a particle-like nature, but we also, because of our free will, can situate ourselves within the broader wave of history, which includes not only all of the past, but all of the future, not just on the Earth, but in the thing that caused the Earth, which is the universe. All of a sudden, we realize that this is much bigger than most people realize. It's not just a fight about light. How do you define light? Is it a particle or is it a wave? Right? All of these problems in quantum mechanics today stem from this inability to resolve these problems that have been resolved already by people like Kepler and Leibniz and Plato. So it's pretty exciting that these are things that I was always depressed to think were just unresolvable. Human beings are just designed to just periodically grow, turn into empires, and collapse cyclically. That's our condemnation. But actually, no, we can break that cycle by just discovering what the oligarchy has been keeping from us. So
They want us fragile, to be easy to manipulate.
yeah, like
This is
soft
what
putty.
you're doing.
Yeah, they don't want us to harden up our minds. Yeah, right, exactly. There's a whole bunch of things on Huygens and refraction and quantum physics, which we can do next time, I guess. You generally judge somebody who's not insane when their words, what they say they're going to do, what they say that their governing philosophy is, and their actions coincide when they're not contradictory, right? So you listen to Martin Luther King, you look at his actions, you see, okay, actions, thoughts, they're not very contradictory. There's something genuine and substantial there. Man's willing to die for a principle that he has expressed and described through reason what it is. You look at an Obama, not the same thing, right? A lot of flowery, nice words, actions, totally another universe. So a society which is fit to survive is capable of thinking with their mind's eye, so that they're not just being swayed by flowery language, but they're able to see with their mind's eye to see the breakdown of words and actions. And if they break down, then you could smell bullshit. You can start thinking critically about, well, what's actually being hidden from me? What is the actual truth that I deserve to know, or that my society needs to know to survive? In science, it's no different. I mean, there's certain, a lot of scientists today, you guys have probably heard this, will say that science cannot tell us why things are, they can only tell us how things are, right? You guys have all heard that type of adage? Now, I mean, okay, if you applied that to your daily life, that I couldn't know why things were, just how they were, you would be dysfunctional. And you could imagine like the insanity of a police officer who believes that, you know, who would say, well, I can only know how that car accident happened. I can only know how that woman got hit. I can know the velocity of the car. I can know how she died by getting run over. But I couldn't know why it happened. Right? If you actually applied that type of ethic to any other part of society which has to do something useful, it wouldn't work. Right? You would never know that there was an intention on the part of the driver to run down his girlfriend who he found cheating on him the week before. You know, that intention is something invisible. It's not something located in the velocity, in the matter, in the space-time of the action of the actual accident. And so, what the scientist is actually saying is, I don't believe in immaterial principles that cause material change. I don't believe in principle. I don't believe in causality. That's why you can only know the mechanics of what makes things happen. You processes within the terms of space-time. That's, so we are representing the mere shadows which the reality of physical processes casts upon our mental image of the kind of empty space-time which is the subject of Euclid's elements. We are thus in Plato's cave, as famously identified in his Republic. We're talking about Plato before. Everyone heard of Plato. People have probably heard of the metaphor of the cave in Plato's works. Yeah? Anybody has not heard of Plato's cave? We've all heard of Plato's cave, okay. All right, so what we're going to do, to put some meat on the bones of that statement, and what I said just before that, let's read the first 6 definitions of Euclid's elements and see is there an internal contradiction in something which is the basis of how all of the leadership is being conditioned to think about economy, the quantum world, cosmology, musicology, a lot of these things that we are told are, you know what, I'm not going to talk about it. Let's just read Euclid and see if there's any contradictions. Euclid says, who wants to read the definitions 1 to 6? Volunteer. Evan.
Definition 1. Point is that which has no part. Definition 2. The line is breadthless length. Definition 3. The ends of a line are points. Definition 4. The straight line is a line which lies evenly with the points on itself. Definition 5. A surface is that which has length and breadth only. Definition 6. The edges of a surface are lines.
Okay, let's stop there. Does anybody okay, who said that they didn't know of Euclid before? They hadn't heard of the name Euclid. Okay. Euclid is a fellow who lived about 2,000 years ago. After Plato died, this is during the time of the height of degeneration of the Roman Empire. And Euclid was a fellow who is accredited with having the formula, but you can't know the reason why the formula is true. And we've all gotten that too in school. I mean, I remember feeling really disturbed when I was sitting in high school, being told I have to memorize all these formulas to pass a test, and being a little, you ask the questions to the teacher, the smart kids in the class, why are these formulas true? Why are these trigonometric functions, why are they true? And nobody can really tell you a very satisfying reason. You're just basically told to memorize it so you can pass the test, and some people are really good at memorizing. Still don't really know what that means. So, what I have printed out for most people here in the audience is the first few pages of Book 1 of Euclid's Elements. We're not going to read all of the definitions, but what Lyndon LaRouche has explicitly stated year after year after year after year is that one of the biggest problems intellectually blocking many of the leading people in society from understanding the true causes of our crisis, whether it be the breakdown of the financial system, whether it's our drive towards accepting the conditions of a nuclear war, whether it's the basic idea that we have to accept conditions of depopulation, of increased suffering for the many, for the benefit, monetarily at least, of just a few. One of the reasons why LaRouche has said that this has been permitted to happen is that there's been a pervasive belief that we have to adopt the methods of thinking of Euclid and sense perception. That the combination of getting society to be conditioned to think that their minds have to be changed to the laws of our 5 senses, what data we've taken from our senses, and the rules and definitions that we're told we have to abide by Euclid. Everybody here heard heard of Euclid before? Little? So, okay, well.
A bit.
Okay. This is at the heart of a lot of the major unnecessary crises that are facing us. And it's by shedding light on these false modes of thinking that we're going to be able to see a very clear pathway out of many of the crises into this world of a new renaissance and a true human civilization based on creative reason that we're talking about. Lyndon LaRouche opened a paper not that long ago where he just said it in his own words. He said, "It should occur to us that in attempting to represent physical unified in an encyclopedic format, all geometrical knowledge that had been developed up until that time into one place, which is called 13 books. It's found in one big volume of pretty much descriptive geometry. So every part of geometry, Pythagoras' theorem, everything. What is the square, what is the triangle, everything that had been known was brought into one place. It's the first time that was done in an encyclopedic way. And he basically says, okay, anybody now who wants to study physical reality, if you want to be a true scientist, you have to study my methods, you have to obey my rules, because he begins his 13 books with a set of definitions and rules. And then, when you do that, now you're free to start going off on your own to explore the physical universe, right? Question is, where did he get these rules, right? Did he discover them, or did he impose them? And if you try to use the language that he's giving you to try to map out the yet unknown universe, do you run into any intellectual contradictions, right? Is there any place where your language breaks down with the actual curvature of the universe that you're walking into, that you're trying to wrap your mind around, that you've never seen before? Or that you're trying to fit your data into and build a model around. Christine got at that very well by introducing the three different models that Kepler had to overthrow in discovering his laws of physical space-time, his musical space-time. So does anybody see any problems so far in those first 6 definitions, in his building up of the universe? Or his definitions of what is the basis upon which the universe is built up? A point is that which has no parts. A line is a breathless length. The ends of a line are points. A surface is that which has length and breadth only. The edge of the surface are lines. Any problem there?
1 and 3 contradict.
Go on.
I don't know, I just see it. How can a point have a line but not have a part?
How could a point?
Like as he defines a point, is that which has no part?
Point equals, yeah, no parts.
But a line.
No width, breadth, or height.
Oh, sorry,
Right?
Yeah. But the ends of
So that's
a
a point.
line are points. But if it's a line and a point, there's a part.
Well, yeah, so a line is made up of is basically, he's saying, is bounded by 2 points, but the points themselves have no width, breadth, or height. And he says also here that a straight line is a line which lies evenly with points on itself. So if you think of a straight line, you start building up all of these points, and you start getting a straight line made of these points lying on itself. How many nothings do you have to add together to start getting something?
Can you please draw a point that has no breadth, width, or height?
Oh, I'm sorry, I just lied to you. I just put breadth and width and height on a point as ink on a board, right? Right, so right there, just my doing this is a contradiction. And then if you take this further into a surface, right, a plane surface is a surface which lies evenly with the straight lines on itself. Okay, so now all of a sudden let's introduce another dimension into our nothingness. Now if we define all of a sudden a two-dimensional surface, he's saying what's it made up of? A plane surface is a surface which lies evenly with the straight lines on itself. Okay, so we've got a whole bunch of nothings that have made up a straight line. We've got straight lines of nothings, essentially, that basically make up a surface. And then in a further book, he starts getting into three-dimensional geometry, and you can imagine starting to add these surfaces together to get all of a sudden his definition of a cube and other volumes, which are made up of a bunch of nothings. So basically, you'd pretty much be thinking that the universe is made up of a whole bunch of